part 2 of function notation. Function notation continued. We're going to go ahead and jump right back into it. Me and the fellowship, we're heading off to destroy the ring of Sauron. So that's what's going to be going on today. So we're going to do some more complicated things, or I think more interesting things with function notation. So here we go. So we can also do what's called combining functions, which is pretty fun. Combining functions is just where you might have an expression that looks like yikes. Let me change. Nah, we'll just keep it purple, whatever. So example 1, we're going to do like a linear combination of these two functions. So we're going to do like -3 times h of 7 plus, let's do 4 times g of 16. That's a really big number. Let's do g of 10. Great. Fantastico. All right, so if we want to figure out what this is, what we do is we can't do 3 times h of 7. We can't do this because we don't know what h of 7 is yet. And we can't do 4 times g of 10 because we don't know what g of 10 is yet. So I'm going to write this basic shell out. Okay, it's 3 times some number plus 4, or -3 times some number, plus 4 times some number. And then what I'm going to do is I'm going to, since this goes to h, I'm going to send 7 off to h, and we're going to end up with 6 minus 7. So I've just taken the 7, I've sent it off to h, and we're putting that in these parentheses because that's the value that we're going to get there. G of 10, I'm going to send 10 off to g, so we get 10 squared plus 22. Oh man, I make myself do math. Why did I do this to me? Oh man, it's brutal. Okay, that's okay. Do some mental math here. -3 times 6 minus 7 is -1. Now for the fun stuff. Plus 4 times, a lot. 10 squared is 100 plus 22. So I'm just going to do this one step at a time. I'll keep this the same because I already know what it is. I'll do the multiplication step at the same time here in just a minute. That'll be plus 4 times 122. Great. What is that going to be? 4, yeah, it should be easy. 6, yep. Okay, so this is -3 times -1 is +3, plus 4 times 100 is 400, 4 times 22 is 88, so plus 488, which will give us the final answer of 491. Whoa, that was kind of fun. Okay, so that's a linear combination of two functions. All right, you're going to do the next one. Try this one on your own. You are going to do, let's do g 5 times, no. That's awfully mean. Yeah, let's do 5 times h of -4 minus let's do 10 times f of 6. 10 times f of 6. You try that on your own, and then we'll go from there. All right, so you should be have tried it. So we're going to do the big reveal here. Minus 10 times some number. We don't know what it is. Now I'm going to send these off to those functions. It goes off to the blue one because it says h, right? So we're going to do 6 minus -4. And then over here, we're going to send that off to f, which is the green one, which is 1/2 times 6 minus 2. Cool beans. Alright, so we end up with 5 times 6 minus -4 is really 6 plus 4. And then over here we have minus 10 times Half of 6 is 3 minus 2. Oh, that's easy. So this is 5 times 10 minus 10 times 1. So that is 50 minus 10, which is 40. That's combining functions. Okay, another thing that we can do with functions, if I say, hey, ladies and lords, this is our function f. Okay, I can ask you questions like, what is f of 5? Tell me what f of 5 is. So what does this mean? This asks a question. What was that question that it asked me oh so long ago, at the very beginning of the lesson? It says, what is the value of the function? This was f of 4, but what is the value of function? The value of the function, or really, what is the y value of the function at x equals 4? We're going to go way, way back. All right, so the y value of the function at x equals 5, I go to 5, I trace up. Oh, it's 3. Look at that. So you guys can pick values. So if you think you've got it, tell me what is the value of f? What is f of negative 8? Okay, so f of negative 8 means you go out to negative 8, trace down, and then go over. It's negative 5. Great. So I want you to tell me these two. What is f of 8? Take that back. I don't like that one. What is f of 10? And what is f of negative 2? Right, so what is the value of the function at? So pause the video, give that a shot. Okay, here we go. Value of the function at 10, we're up at 6. Okay, tracing over, following the height, kind of the height of our function. What is the value of my function at negative 2? Oh, that's a little harder. It's not really on a grid line. It's hard to be sure, but just for the sake of the video, we'll say that we're at like 1.5. So the value of the function doesn't have to land on a grid line. Right here, it looks like we're at like 2, and then it's at like 2.5, and then maybe a little bit more, 2.6, get 2.7, 2.8, 2.9, and then we're at 3. So like you can see it slowly climbing, so you might not get a perfect answer when you figure out what that is, or what the value of the function at a number. You may also see questions that look like, for what values of x is f equal to, we will say f of x equal to, so for what values of x is the value of our function equal to 5? For what values of x is our function equal to 5? Okay, so our function's down at negative 5 climbing up. When does it get to 5 on the y-axis? Gets to 5 at, it's at x equals 8. Okay, so you can ask questions like that as well. This is the reverse. So this is asking, hey, I'm giving you an x value, you tell me the y value. This is asking, hey, I'm giving you this y value, the 5. The height of our function is at 5. What values of x is it equal to 5? Well, that's at 8. Okay, you can do the same thing with the table. What is f of 9? What is the value of my function when x is equal to 9? So it's saying, this basically is saying, remember this is, or not, I'm sorry, this is the function a. Classic mistake. Okay, here's our function a of x. I want to know what a of 9 is. What is the value of my function when x is 9? So I go down to x equals 9. Oh, it's equal to negative 8. Okay, you guys tell me, what's the value of a at 26? What is the value of a at 3? Okay, pause the video, give those a shot. Value of a at 26 is 5. Trace on down. The value of a at 3 is negative 15. That's A. Okay, so this is asking for a y value when you see something like this. Similarly, you could say, for what x values is A equal to 9? For what x value is A equal to 9? Well, when is A equal to 9? Oh, it's equal to 9 right there. Haha. What x value? X equals 40. Okay, the last thing I want to go over is something called compound functions. Compound functions. So with a compound function, that is when we take a function and put it into another function. So, for example, let's do a couple. Let's do h of g of 0. H of g of 0. This is read h composed of g composed of 0. I'm probably thinking like, Slago, what are you doing? Are you nuts? What is going on here? This is crazy. All right, so what you're doing, it's really not that bad. Not too bad. In blue, you're doing h of, and then on the inside, you always start your problem in the innermost section and then work your way outwards. So you start at the very inner. We can't say, I can't send g of 0 to h until I know what g of 0 is. So that's what we're going to do. The first thing that you do is you figure out what g of 0 is, which is just 0 squared plus 22. Okay. All right. 0 squared plus 22. So now we're going to simplify that on down. I'm going to come on down. So that's h of 0 squared is 0 plus 22. H of 22. Oh, hey, I know what g of 0 is now. G of 0 is equal to 22. So now I can take 22 and I can send it to h. So that's what I'm going to do. I'm going to send that off, and that's going to be 6 minus 22, which is something. 16, negative 16. Is that right? 16? Yeah. Yeah. So what is h of g of 0? H of g of 0? Oh, so fun. Compound functions. H of g of 0. Cool. Okay. Yeah, it's negative 16. Great. Example 2. Let's see. Well, is that going to be the same? Take a minute and think. As g of h of 0. Will this be the same? Again, we're starting at that innermost section. Okay, let's do this. And then I'm going to make sure the last one's extra tough for us. Okay, g of h of 0. So I'm going to plug in first, this time, g's on the outside. So it's going to be g of, in red. And then on the inside, we got our blue one. H of 0 is 6 minus 0. Oh, this is easy, they say. I think I'm losing my mind. I'm like talking to myself. So this is just g of 6. Hey, I think we can do that. Send 6 off to g, and you'll get that's 6 squared plus 22. 6 squared is 36. Plus 22 is 58. Exciting, exciting. So it turns out that h of g of 0 and g of h of 0 are not the same thing. Interesting. I'm going to do one more example. Hopefully we have room over here. Sure doesn't look like it. I'm just going to insert a new slide. I'm going to copy this. We're going to grab a new page and paste. And I'm kind of just winging it off the cuff here. But that's okay. What I'd like to do now is we are going to do f of f of, what shall we do? 14. I'm so evil. Mwahahaha. I think I'm Sauron. Quit looking at me like that. Come on, come on. F of, now what I'm going to do is I'm going to send 14 off to my function. So you can do f composed like of itself, kind of. Send 14 off to my function. You get 1/2 times 14 minus 2. That is f of, half of 14 is 7. Easy peasy. Minus 2, no problem. Okay, then you get, that's f of 5. Okay, so now we know what f of 14 is, so we can send, it's 5, so we can send that off to our function, and we'll get 1/2 times 5 minus 2. All right, now we're a little bit in trouble. 1/2 times 5, 1/2 times 5 over 1 minus 2. That is equal to, multiply across the top, 5 over 2 minus 2 over 1. We got some fractions. They need to have the same denominator, so that is 5 over 2 minus 4 over 2. And 5 minus 4 is 1/2. Who'd have guessed that f of 14 is 1/2? So now you know lots about function notation and all the cool things that you can do with it. It allows us to express computations really easily. You can just write f of something, and it means plug something in, or go check and see what the value of the function is here. It also allows us to name different functions so that we can verbally compare, and in our writing, we can compare how different functions behave. And that's a really useful skill to have as mathematicians. So from all of us here in Middle Earth, thank you for tuning in to the Mathnasium, and I hope this was a helpful video for you. We'll see you next time.